Hello, hello everybody. So the chapter solution and colligative property will start with the main topics of in this chapter is concentration terms, vapor pressure, colligative properties, that is RLVP, relative lowering and vapor pressure, elevation in boiling point, depression and freezing point, and osmotic pressure, Van't factor, and solubility of gases. So first we will start with the solution. So first of all, the definition of solution is a homogeneous mixture of two or more components. It may be two components or more component. And solution is divided into two parts mainly: solute, which is generally present in small amount, and solvent, which is present in excess. For example, if we take 40% ethanol solution in water, so solute is ethanol, solvent is water. So if we take 60% ethanol solution, then solute is water and solvent is ethanol. So here we have 100 ml water and we added 10 gram sugar. It means this sugar is a solute and water is a solvent. So solution is the present in the same phase as that of the solvent. Means like solution will look like a water because it's liquid. It will not look like a sugar. So in this way you can recognize which is solvent in the mixture. So next we will explain the concentration terms. Concentration terms are the methods of expressing the concentration of solution. We divided two categories, A and B, group A, B. Group A is volume related, group B is mass related. So the terms which are in group A, they are temperature dependent because volume depends upon temperature, and the terms which are in group B, they are temperature independent because mass temperature has no effect on the mass. So these are the four terms which are in the concentration terms which are come under group A: percent by volume, percent weight by volume, molarity, normality. And these are the four terms which come under group B. Number one is percent by weight by mass, mole fraction, molarity, and ppm. The relation between these two is density. You can interconvert the group A property to group B by multiplying or dividing density. So now we will discuss one by one. So first is percent by volume. It's V by V. So it is according to definition, it is volume of solute, volume of solution into 100. So volume is an extensor property. So volume of solution can be written as volume of solute plus volume of solvent. So this formula become volume of solute plus volume of solvent into 100. This is with respect to the solute. If you want to write with respect to the solvent, you will write here volume of solvent, volume of solute plus volume of solvent into 100. Simple. So as we have, suppose 20% ethanol aqueous solution, volume by volume, suppose this is given. So when V by V is given, it means your solute and solution both are in the liquid form. You will measure them in ml because percent is there, it means that will be out of 100. So what is the meaning of this line? Is 20 ml ethanol is present in 100 ml solution. So you can write here 20 ml ethanol plus 80 ml water. So moving to next, here is a problem. First, how many ml of ethanol should be added into 50 ml of water to obtain a solution containing 80% V by V of solvent. Now here V by V of solvent is given. So 80% V by V solvent means 20% V by V solute. So apply the same formula, percent V by V, V solute upon V solution. So in this way you can calculate it, 62.5 ml. Second term is percent weight by volume. Now here is a weight by volume, means your solute will be in gram and volume will be 100 ml out of 100 because percent is there. So it is weight of solute divided by volume of solution into 100. So there is a simple definition. An aqueous solution contains 30% weight by volume of urea. It means 30 gram, 30% weight by volume means 30 gram urea is present in 100 ml solution. So if the density of solution is 1.2, so the density of solution is given, then you can calculate these three mass of solute, mass of solvent, and mass of solution. Because density is given, so you can calculate the mass of solution, and mass of solution minus mass of the solute, you will get 90 gram mass of solvent. Okay, now third term is molarity. Definition of molarity is the number of moles of solute dissolved per liter of solution. So it's M is number of moles of solute, volume of solution in a liter. So here we will assume that solute means B, solvent means A. Like NB means number of moles, N solute B, NB number of moles of solute, V is volume of solution. So if you take ml, you multiply it by 1000. Number of moles are calculated as weight of the substance given divided by molar mass. So overall formula of molarity is WB upon MB into 1000 upon volume in ml. WB is weight of solute, B means solute, MB is molar mass of solute that you can calculate from the formula, and 1000 divided by V ml means the volume of solution given. Then we move to the problem number 2. So here problem number 2 is 30 gram urea is dissolved in sufficient water to produce 250 ml solution. Find molarity. Very simple. Here solute is urea. So in this formula put the value, just WB is 30 gram. MB molar mass of urea is calculated as 60. 1000 upon volume is given 250, so you can calculate easily. Here are some terms like 2 moles of solute present per liter of solution. What is the meaning of 2m? It means 2 moles of particular solute present in 1 liter of solution. If you have a 1 molar, it's called 1 molar simple. If we have 0.1 or m by 10, it's called decimolar. If we have 0.5 molar or m by 2, it is called semimolar. 0.01 is called centimolar. 0.001 is called millimolar. These are the terms which are generally used in the numerical problems. Then come to the fourth terms of the group A, normality. It is number of gram equivalent of solute. Instead of number of moles in molarity, we have number of gram equivalent of solute present per liter of the solution. So what is N? N is number of gram equivalent of solute, volume of solution into 1000. So how to calculate number of gram equivalent? Number of gram equivalents are calculated from the molar mass. Like if we compare normality and molarity and normality, so these are the formula WB upon MB 1000 upon V, WB upon EB here. EB means equivalent mass of the solute. Only difference is this. Here we have a molecular mass or molar mass of solute. Here we have a equivalent mass of solute. Now how this equivalent mass of solute calculated? So calculation of equivalent mass. So case 1 for acids like HCl, H2SO4, nitric acid, phosphoric acid. How we can calculate the equivalent mass? So the formula is equivalent mass equal to molar mass upon basicity. What is basicity? Number of ionizable hydrogen ion given by one molecule of acid. If the number of ionizable hydrogen is 1, basicity is 1, you divide the molar mass by 1. If the number of ionizable hydrogen is 2, basicity is 2, divide the molar mass by 2. Like here are some examples. First example is HCl. It gives 1 H positive ion, so basicity is 1, so equivalent mass is 36.5. For sulfuric acid, it gives 2 H positive ion, basicity is 2, so divided by 2. For phosphoric acid, so it gives 3 H positive, this is the structure, so 1, 2, 3, these are the 3 ionizable hydrogen, you divide by 3. Phosphoric acid, according to the structure, it has only 2 hydrogen which are ionizable, so its basicity is 2, this is very important. Equivalent mass is molar mass by 2. Now case 2 is for bases. For bases like NaOH, KOH, calcium hydroxide, aluminium hydroxide, how we can calculate the equivalent mass? So equivalent mass is molar mass by acidity. Now acidity is number of ionizable OH negative ion. So like NaOH give only 1 OH, so acidity is 1, so equivalent mass is equal to molar mass. Calcium hydroxide gives 2 OH negative ion, so its acidity is 2, so molar mass divided by 2. Third case is for element. Per element, equivalent mass equal to atomic mass by charge. For example, equivalent mass of oxygen is 16 upon 2, 8, because oxygen has 2 charge. hydrogen is 1 charge divided by 1, aluminium has 3, so aluminium has equivalent mass equal to 9. So these are the methods how we can calculate the equivalent mass. Now to apply this equivalent mass normality, then problem third. 9.8 gram H2SO4 dissolve in sufficient water to make 250 ml of solution. Find normality and molarity. We have to calculate normality and molarity. So these are the formula. Molarity is WB1 MB, you know the 1000 upon VML. Normality is AB. So WB is 9.8. Molar mass of sulfuric acid is 98. Volume given is 250. You can calculate 0.4 molar easily. Now in this case we have a equivalent mass, and equivalent mass of H2SO4 is 49 because its basicity is 2 as discussed previously. So it is 9.8 divided by 49, so it comes to 0.8. So this is the relation between normality and molarity. When normality equal to n into molarity. N may be acidity or basicity. For acid it will be basicity, and for base it will be acidity. Now problem 4 again. If the solution given is 20% H2SO4 aqueous solution weight by volume. Now find normality and molarity. Very easy. First of all, write the meaning of this. 20% H2SO4 aqueous solution weight by volume. Its meaning is 20 gram H2SO4 is present in 100 ml solution. So we have 20 gram H2SO4. That is, you can use the formula of molarity. 20 upon 98, 1000 upon 100 ml solution. So you will get 2.04 molar. For normality, here we have a 49. So it's come out to be 4.08. You can calculate molarity. If you can calculate molarity, so molarity multiplied by 2, you will get the normality. So you can also use this relation. Moving to group B, here we have a group B. So in group B, first is the percent by mass, called percent by weight or percent weight by weight. So percent weight by weight is, as weight by weight means weight of solute, weight of solution into 1000. The weight of solution can be written as weight of solute plus weight of solvent. Now this is a simple problem. 5 moles of glucose dissolved in 2 liter water. If density of resulting solution is 1.5 gram per ml, calculate number 1 weight, percent weight by volume, percent weight by weight, and molarity. So first of all, percent weight by volume. Weight of solute can be calculated from 5 moles of glucose. 1 mole of glucose is 180. 5 mole of glucose is 5 into 180. Then volume of solution 2 liter 2000 ml into 100 is 45%. Weight by weight means we have to take the weight of solute as well as weight of solution. Now weight of solute is again same 5 into 180. Weight of solution is calculated from density. So mass of solution is 1.5 into 2000 come out to be 3000 gram into 130. So there is a direct relation between these two, percent weight by weight and weight by volume. You can calculate like percent weight by weight into density equal to percent weight by volume. So this is percent weight by weight. Multiply it by density. What is density here? 1.5. So 30 multiply 1.5 come out to be 45. So you can use this relation also. Third, we have to calculate the molarity. Molarity is just a simple number of moles per liter. So there are 5 number of moles and solution is 2 liters, so it's 2.5 molar. Second term in the group B is mole fraction. So here is a definition of mole fraction. Ratio of number of moles of one component, one particular component may be solute or solvent, to the total number of moles of all the component present in the solution. Like if you want to calculate the molar fraction of solute, you take the number of moles of solute divided by total number of moles. If you want to calculate mole fraction of solvent, so take the number of moles of solvent divided by total number of moles. Simple. Suppose we have a 2 component A and B. A is solvent, B is solute. So given masses WA gram, WB gram respectively, molar masses say MA, MB. So first of all you calculate the number of moles, that is WA upon MA, WB upon MB. After that apply the formula of mole fraction. So mole fraction of A, XA is equal to number of moles of A divided by total number of moles. What is XB? Number of moles of B divided by total number of moles, and sum of the mole fraction of all the component is always 1. Whether the solution contain 2 component or 3 component or 4 component, but the sum of the mole fraction of all the component is always equal to 1. Next, move to third property, that is molarity. Is very important. Definition: number of moles of solute present per 1000 gram of the solvent. Say NB, volume of weight of solvent in gram. If you take in gram, multiply by 1000, otherwise in kg. So formula become WB upon MB, 1000 upon WA. So this simple problem, if we given a 28% weight by weight of KOH, suppose this is given. So what is the meaning of this? Is 28 gram KOH present in 100 gram solution. Weight by weight means 28 gram KOH present in 100 gram solution. So just put the value. WB is 28 gram. Weight of solvent, that can be calculated by, from here, weight of solution minus weight of solute. 1000 minus 2872. So put the values, you can calculate the molarity. So some special formula related to these terms. First is relation between molarity, percent weight by weight, and density. Because this molarity belongs to group A, percent weight by weight belongs to group B, so they can be interrelated or can be interconverted by using density. So this is the relation 10 into percent weight by weight into D upon MB, or this is, you can use this relation also, and from this you can derive this relation. Second is relation between molarity and density. Again, molarity and molarity, they belongs to two different groups. Molarity is of group A, molarity is group B. Again, density is required. So this is the formula. 1000 M, M is molarity, small m is molarity. 1000 D, D is density, minus M molarity, MB is molar mass of solute. The third is relation between M and XB. M is molarity, XB is mole fraction of solute. So they belongs to the same group, so density is not required. So the simple formula is XB upon XA into 1000 upon MA. So these are the direct relations which can be used for in calculations. Problem 8.